and welcome back to Ganesh Institute channel. So in today's video we are going to discuss about Chinese remainder theorem. This theorem is important from the perspective of algebra as well as cryptography. So let's get started. Here one question is given to you which states that x is congruent to 1 modulo 3, x is congruent to 2 modulo 5, and then x is congruent to 3 modulo 7. What you are supposed to do, you have to find out the value of x. Okay, so how you can do it? First of all, you need to compare this as if it is a1 modulo m1, a2 modulo m2, and a3 modulo m3. So if I ask you what is a1 here, 1, what is a2, this is, if you compare, this is 2, what is a3, this is 3. What is m1? So after modulo we have m1, that is 3. What is m2? This is m2, okay, 5. And what is m3? 7. Now the first condition to check whether Chinese remainder theorem, that is CRT, is applicable or not, you need to see that if the GCD, that is greatest common divisor of m1 m2, m2 m3 and m3 m1, are these relatively prime or not? That is, if you take their LCM, that should be 1. Their HCF should be 1. So there should be nothing common apart from 1 in these two pairs. So yes, we can see that nothing is common in 3, 5 except 1. Nothing is common in 5 and 7 except 1. Nothing is common in 3 and 7 as well except 1, right? So we can apply our CRT, okay? Now how should we go about it? So if you see, we have, firstly, the formula is M. You need to find out capital M, and that is the product of M1, M2, M3, okay? So that means it goes like 3 into 5 into 7, 15 sevens are 105. So we got our M. Now you need to find out capital M1, capital M2 and capital M3. For that you need to do, you have find out your capital M, divide it with small m1. Similarly do it for m2 and m3 as well. Okay, now what is your capital M? It is 105 everywhere, and then divide it by m1, m2, m3. m1 is 3, m2 is 5 and m3 is 7, right? So you got here 3 3s are 9, 3 5s are 15, 35, 5 2s are 10, 5 1s are 5, 7 1s are 7, 7 5s are 35. So you got your m1, m2, m3, right? Now the main formula. The formula goes like x is congruent to a1 m1 m1 inverse modulo m1, and do it for second and third value also. So a2 m2 m2 inverse modulo m2 plus a3 m3 m3 inverse modulo m3, and multiply this whole thing with modulo m. Okay, so let's put down all these values. So that means you need to find out a1. Your a1 is 1, m1 is 35, m1 inverse is 35 inverse modulo small m1, that is 3, right? You can see your a1 is 1 and m1 is 3. Similarly 2 5 3 7 we need to take. So second is a2, which is 2, m2 which is 21, and m2 inverse 21 inverse modulo 5, which is m2, small m2. Then a3, which is 3, m3, you've got it as 15. Then m3 inverse, 15 inverse, modulo small m3, that is 7, and modulo capital M, that is 105. The product of all three modulos which are given to you. So I'm hoping that you've got till here. Now we need to find out, let's simplify it a bit. 35 ones are 35 into 35 inverse mod 3. Then 2 ones are 2 to the 4. 42 into 21 inverse modulo 5. Plus 15 3s are 45 into 15 inverse modulo 7. Into mod 105, right? So good so far. Now we need to find out the inverse. That is a new thing. We have not got it. How to find it? We have not learned it yet. So let's try. For inverse, treat your question like, so you have to find out 35 inverse mod 3 first, right? We'll find out all these three values. So first up, 35 inverse mod 3. Assume it as if it is x1. Okay. So can I write it as 30? If you take it, this 35 inverse here, 35 inverse, it will become 35 x1 1 modulo 3. Okay. So 35 x1 1 modulo 3. Now whenever there is modulo, you need to understand which set does this modulo 3 belong to. So we have, always remember, if I have Zn as my set, so it will contain the elements from 0 to n minus 1. Okay. So Z modulo n contains elements from 0 to n minus 1. That means modulo 3 will contain from 0 to 2. Yes or no? So keep putting down these values. 0 into x1. In place of x1, just put all these three values and find out which is satisfying this equation. That is, what is happening when I am putting x1 as 0, 1, 2? Is it giving me 1 modulo 3 or not? So let's try. Firstly, I am putting here 0. Okay. If you put here 0, 35 0 0. So now 0 congruent to 1 modulo 3. Is it true? No. Because what we have to do? We have to find out it this manner. Let's say I have 12 modulo 3. Okay. So we have to divide 12 by 3 and we get, we can divide 3 with 12. That is 3 4s are 12. So remainder is 0. So that has to be 0 value. Okay. So because here 1 is there, remainder is not 1. Right. If we divide this, remainder cannot be 0. So we cannot consider this. Now next, let's put 1 here in place of x1. Right. So if we place 1 in place of x1, what we will get? 35 into 1, 1 modulo 3. Let's check if it is true or not. 35 is 35. So divide it. If you divide it, what we will get? 3 ones are 3. 3 ones are 3, 2. Right? So the remainder has to be 2. But we are getting 1. So this is also not right. Correct? So let's move on to next, which is the last element. That is 2. So if I place 2 in place of x1, we get what? 35 2s are 70. If we divide it by 3, 3 2s are 6, 3 3s are 9. So we are getting remainder as 1. So that means it is correct, right? So we can consider the value of x1 as 2. So our x1 is 2. That means this whole value 35 inverse modulo 3 is what? X1 is 2. So we will place here, in place of this 35 inverse modulo 3, we will put 2. Okay. Next, we will find out this 21 inverse modulo 5. So for 21 inverse modulo 5 and then 15 inverse modulo 7, these two we have to find out, right? Here you can see 15 inverse modulo 7 and 21 inverse modulo 5, right? So let's find this out. So again we'll treat it as, consider y1 and this as z1. Okay, anything, any arbitrary constant variable. Now can I consider as, if I take this here, 21y has to be 1 modulo 5, and from here 15z1 should be 1 modulo 7. And when it comes to modulo 5, that means the elements should be from 0 to 4. And here it is modulo 7, that means elements to be checked from 0 to 6. Right? Okay, now let's put the value one by one. So we have firstly 0. If we place here 0, 21 0 0, we cannot get 1 as remainder. If we place 1, 21 ones are 21. So if I divide 5 4s are 20, remainder is 1. So it is satisfying the condition. So our y becomes 1. Okay, you can try on other values also. From here, if I place 0, 15 zeros are 0, we cannot get remainder 1 if we have 0 here. Then if I place 1, 15 ones are 15. If I divide it with 7, 7 twos are 14. So remainder is 1, correct? So that means it is satisfying the condition. Which value? 1. So Z1 is also 1, correct? So let's put down the values. We've got here Y1 as 1 and Z1 as 1. We got X1 as 2. So now place all these values here at 3 places. So what have we got? Our X becomes 35 and the 35. 35 inverse modulo 3 was 2. Plus 21 twos are 42. 21 inverse modulo 5 is 1. So I'm not writing 1. 15 threes are 45. 15 inverse modulo 7 was again 1. And then outside was modulo 105, right? So this becomes 35 twos are 70. 42. 45. Modulo 105. And then that means it becomes 7 4 11 and 4 15. 157 modulo 105. Now how we have to solve it? It is a basic modular equation. So what we do to find out x? Simply divide this. Divisor is 105. 157 is the dividend. Divide it. So we get 57 as remain. Have we got it right? 7 minus 5 is 2. So this is 52 as remainder. So it is 52 modulo 105. Either you can say that value of x is 52, or you can say, because you know that it means it will be divided by, this is the remainder, right? So for remainder the equation has to be, and this how we can elaborate it? 52t plus 105t, where t can be anything from integers? Yes or no? 52 plus 150. Hold on. You can see what we have to do now. This is our remainder. Yes. And this is our divisor. What we do? A is equal to BQ plus R. Or we can say by division algorithm, dividend is equal to divisor into quotient plus remainder. Yes. So this is what we have got in this form. We can put any of the t values and we can get, infinite solutions. But as far as the answer is concerned, we can have this 52. I'm hoping that you got it. If so, then don't forget to like, share and subscribe my channel. Till my next video, take care of yourself. Bye-bye.